A switch has been closed. A switch has been closed for a very long time before t equals to 0. At t equals to 0, the switch is open. The switch is open at t equals to 0. The value of the voltage, just after the switch is open at t equals to 0 plus. After the switch is open, find the voltage across this 10 kilo ohm resistor. So we're going to have to first look at the total current flowing in this circuit at t equals to 0. Because remember, the inductor will change its voltage to keep the current flow at t equals to 0 plus after the switch is open, same as the current at t equals to 0 minus, which is before the switch was open. Alright, so remember we have a DC voltage over here at 12 volts. How does a inductor react to a DC voltage? Well, it just acts as a closed circuit, as a short circuit, right? So the current will take this route, go past this 0.2 ohms, right? So current is flowing in this direction. Very little, almost zero will go here, because look at the value of this resistance. It's too high compared to that of 0.2 ohms. So most of the current, almost all the current will flow through this 0.2 ohm and then return back to the circuit. Correct? Pretty simple here. So let's find out the current here. So the current is just simply going to be the Ohm's law here. So IL equals to V here, V over R, correct? Now what is V here? V is simply just 12 volt. And the resistance is basically a sum of these two, 24 ohm plus 0.2 ohm. So we get 24.2. And if I do the math here, I basically get 0.496. 0.496. Of course, the unit is going to be the amps over here, right? Now let's move to at t equals to 0 plus. After the switch is open. Now the switch is open. Same current is going to flow across this 10 kilo ohm resistor, right? Now the current is going to go in this direction. Because your inductor is now going to act as a source, right? So it's moving in this direction, correct? Now what's going to happen? I'm going to just simply apply V equals to I times R to find out the voltage across this resistor 10 kilo ohm. Now current is already known to us, and that's 0.496. The resistance here is 10 kilo ohm. So I have 10K here, correct? Now, if I do the math, I get the voltage 4960 volts here, correct? Now, the tricky part here, we are not going to have this voltage in positive. Instead, it's going to be negative. And why it's negative? Because if you look at if you apply the mesh here, or if you look at it, you're going clockwise. The polarity here does not match with the polarity we have over here. So if you're going this way, if you're going negative to positive, and then positive to negative. So the polarities are not same, right? Negative to positive is like climbing up on the hill. Positive to negative is like going down. So we have to have a negative sign here, correct? If this was negative and this was positive, now if we look at the loop going in a clockwise direction, we negative to positive, then we would have it in positive. But because there is a polarity mismatch, there's going to be a negative sign. Remember that, this is very important.